Welcome to Calculus Homework, page 286. We're doing implicit differentiation today, which means we're going to take the derivative as we go across. And of course, anytime we take the derivative of y, implicit differentiation says we have to indicate that by using y derivative. So first of all, what's the derivative of this? We know it's 6x squared minus 2y, but since we've taken the derivative of y, implicit differentiation says we have to do that. We have to say y derivative equal to 3, and once again, y derivative. Now, since we're trying to find y derivative, we need to get all of our y derivatives on one side, everything else on the other. So we're going to add 2y derivative to both sides. That will give us 6x squared equal to all of this. And the purpose of this was to find the derivative, so we need to solve this equation for y derivative. Those two expressions have that in common, so let's factor that out. That'll leave us with 3 plus 2y equal to 6x squared. We're trying to find y derivative, so we will divide both sides by 3 plus 2y. Here it cancels. So we get y derivative equal to 6x squared, 3 plus 2y. And that is our answer. Okay, let's look at number 2. Notice on this one there is a product. Do you see the product, x times y? That means when I get to that point, we'll have to use product rule. Let's go ahead and start. What's the derivative of this? It's what? 3x squared minus, and now we need our product rule. First times derivative of the second plus second times derivative of the first, which is just 1. Plus, and now the derivative of this, 2y derivative equals, and of course the derivative of any constant is 0. Now what we need to do is we need to do some distributive and solve for y derivative. So it stays the same. We have a minus, so we want to take the opposite. That's why we put these parentheses after that minus also here, to remind us that we're going to need to distribute that minus to everything. An opposite of a positive y is a negative y. And we are solving for y derivative. So it means that we want to get everything that is not a y derivative on the other side of the equation. So let's add y both sides, and let's subtract 3x squared from both sides. That's going to leave us with negative xy derivative plus 2y derivative equal to all of this stuff. These have a y derivative in common. And factoring that out, that leaves us with negative x plus 2y equals all the stuff on that side. Our last step, divide. So we get y derivative is equal to all of this. Probably on the AP they would put the positive things first, so they'd switch the order there. So that would be your answer for number 2. Number 3. You notice we have product and another product. So we're going to have two product rules this time. So we'll start with this one. We have first times derivative of the second plus second times derivative of the first. And now product rule for this one. First times derivative of the second, which is 1, plus second times derivative of the first, which is going to be 2y derivative, because implicit differentiation, anytime we take the derivative of y, we have to make sure that we put the y derivative to show that we did that. Derivative of a constant is 0. This time we have just either a plus sign or nothing in front of the parentheses. If you remember, we said if there is nothing or plus sign in front of parentheses, we can just ignore the parentheses. We want to solve this for y derivative. So everything that is not a y derivative, let's move over to the other side. So let's subtract 2xy from both sides and y squared from both sides. That is going to leave us with x squared y derivative plus, if we change the order here, 2xy y derivative equal to negative 2xy minus y squared. We have y derivative in common. X squared plus 2xy. Our next step will be to divide both sides by x squared plus 2xy. These cancel. And we're left with y derivative is equal to all of this. I know that I need to factor derivatives when I can. These are both negative, so they have a negative in common. They also have a y in common. Negative y times what is negative 2xy? You're correct, it's positive 2x. Negative y times what is negative y squared? That would be negative, would be a positive y, because negative y times positive y is y squared. Now in the denominator, we have an x in common. X times x would give us x squared. X times what would give us 2? So it would be 2y. That looks like something might cancel, but you'll notice that, okay, it's not exact. Those are nowhere near the same. So that's as far as we can go with that answer. Okay, number 4. We have another product. We'll let all of this be the first part of the product. We'll let cosine y be the second part. So product rule, we have first times derivative of the second. Okay, cosine is a shell and y is chocolate. So first let's do the derivative of shell, which is going to be negative cosine y. Then you've got to do derivative of the chocolate, which is y derivative. So that's first times derivative of the second plus second times derivative of the first equal to, and the derivative of 1 is 0. Now we need to solve this for y derivative, but before we do that, notice all this is one product. We can rewrite that as negative 2 sine x cosine y, y derivative. This we can move all over to the other side. And if we subtract this from this side and move it over there, They'll give you negative 2 cosine x cosine y. We are looking for y derivative, so we can divide both sides by everything else. Do this, all this over here cancels, and that leaves us with y derivative. On this side, the 2's cancel, the cosine y's cancel, and we're left with cosine x over sine x. If you remember from trigonometry, cosine x divided by sine x is equal to cotangent x. And that would be the final answer. All right, that concludes this page. Thank you for watching.